More simplifying radicals. The first problem we're going to do on this worksheet, which is part of your homework, is kind of to review what we worked on with simplifying yesterday, and that is with question number 13. So when we multiply radicals together, okay, we need to remember that just all of these things are multiplied, the 3 times the square root, the 5 times the square root, and then all of these things underneath the radical are just multiplied. So the first thing we do when we multiply is we just go ahead and multiply the plain old numbers together, and 3 times 5 is 15. So then what we do is we take all of the things that are under the radical and multiply them together. They're separate right now, but we're going to put them all together under the same radical and multiply them all together. So this is kind of the reverse of taking two factors under the same radical and separating them apart to give them their own radical. Now we have two separate radicals we're multiplying together, so we're just going to multiply the pieces underneath. And again, these are all just multiplication. So now what we can do, the 15 isn't going to change right now, but we can again go back and multiply the 2 and the 14 together to get 28. Multiply n to the third and n to the fifth, that would be n multiplied together, 3 plus 5, 8 times. And then we have t to the fifth. So now I have it all multiplied together, and now I need to work on simplifying. So when I simplify what's underneath this radical, remember, I cannot have any perfect square factors under the radical. Well, there is a perfect square that goes into 28, and that's 4. So what happens now is we take what's under the radical and separate it into perfect square factors. So this 28 would become 4 times 7. N to the 8th, any variable to an even power is a perfect square. The t to the 5th is not a perfect square, but t to the 4th is, and t to the 4th times t to the 1st would give us those two factors that make t to the 5th. Once I have them separated into perfect square factors, then I can take the square root of each of those individual factors separately. So when I do that, again, the 15 stays there, but the square root of 4 is 2. The square root of 7, that is an irrational, non-repeating, non-terminating decimal, and no more perfect squares go in there, so that just stays under the radical. N to the 8th, the square root of it is n to the 4th. T to the 4th, the square root of that is t to the 2nd. And then finally, the square root of t to the 1st is, again, not anything that is a perfect square. So now I have taken and gotten rid of all the perfect squares that are underneath the radical. And so what I do is multiply all of the things that are outside the radical together. So that would give me 30 n to the 4th, t to the 2nd, and I multiply all the things that are under the radical back together under the radical. So that gives me a final answer of 30 n to the 4th, t to the 2nd, times the square root of 7t to the 1st. And of course, you don't need that one variable there. So now I'm going to go back and see if I can find that answer. And I'll highlight that. Here it is. So that kind of reviews some of the simplifying process. Now, we also talked about how one of the things is you cannot have any perfect squares under the radical. If there are, then it's not in simplest radical form, and that's why we needed to simplify number 13 after we multiplied it together. Another one of the processes, you can't have any fractions under the radical, but we also cannot have a radical in the denominator. So if we look at question number 12, we have a radical in the denominator. We have to get rid of that. So what we are going to do here is we are going to multiply this fraction by a value of 1. We're not going to use the number 1, but we're going to use whatever that square root is, so the square root of 6 over the square root of 6, because that has a value of 1. Anything divided by itself is 1. So now that what that gives us is it gives us 4 times the square root, and again, I'm going to put the 10 times the 6 under the same radical, over, and then the square root of 6 times the square root of 6 is going to be the square root of 6 times 6 under the same radical. So now what that gives us is 4 times the square root of 60 over square root of 6 times the square root of 6 is the square root of 36. Well, now what that gives us is it gives us the square root of 36, which is just 6. So we've gotten rid of that radical on the bottom. But the problem with this question is we still have a perfect square that is under the radical. So if we look at the square root of 60, there's still a perfect square that goes into 60. So we need to take 60 because 4 is a perfect square and it goes in there. So we need to take 60 and break it into 4 times 15. Then again, we are going to take the square root of each individually. And so what we end up with now is we get 4 times the square root of 4, which is 2, times the square root of 15 over 6. So 4 times 2 is 8. So that gives us 8 square root of 15 over 6. And so now that is our final answer. So there's a lot of steps to these. That's why you need to either have more paper or, show your work for sure. So now let's find that on this page. And it is right. It is not here. So 4 times 15, 4 times, am I just not seeing it? Oh, well, I'm not seeing it because I forgot to tell you one other important piece. And the other important piece is this. We need to look at this 8 over 6 as a fraction. And if you can reduce that fraction, you need to do so. So, turns out that is not our final answer. So we need to reduce that fraction, and 2 goes into each. So that gives us 4 square root of 15 over 3. There we go. Sorry about that. So there we go. There's our final answer. And then we find it right over here. All right. So that reviews some of the things we worked on yesterday. So now let's talk about what is new for today. Well, what we are going to work on today is adding and subtracting radicals. So if you look at number 7, we can only add or subtract like radicals. What that means is it has to be the exact same letter or the exact same number or letter and number combinations under the radical in order for you to be able to add and subtract them. They work a lot like variables. Since those are the same, what we do is then we can take 8 square roots of x and subtract 1 square roots of x for a total of 7 square root of x. Now, this other variable in here, right here, is a y, okay? And we cannot add or subtract or combine that because it's not a like term. So that just comes along for the ride, just like with variables. So that would just give us plus 3 square root of y, and combined that is our answer. So 7 square root of x plus 3 square root of y is our answer for this question. And we can see that answer right here. All right, so that is kind of the new skill that we worked on, was multiplying those radicals together and then adding and subtracting. The last question I want to take a look at is question number 14. And if we look at question number 14 right now, and we look at the radicals, we have 12, 27, and 30. None of them can be combined because none of them are the same number. But if you look at the square root of 12, that is not in simplest radical form because 4 goes into 12 and 4 is a perfect square. So what we need to do with number 14 here is we need to make sure each of the pieces of this expression, each of the terms, is in simplest radical form. So we just got done talking about the fact that 4 goes into 12. So for this first part, we'd separate the 12 into 4 times 3. Then we would give each their own radical symbol, take the square root of each separately. That gives us 7 times 2 times the square root of 3, or 14 square root of 3. All right, so what about the next term? Well, the next term also has a perfect square in it because 9 goes into 27, 9 times 3. So then again, I give each of the factors their own square root sign, and this becomes negative 5 times 3 times the square root of 3. And now this gives us negative 15 square root of 3. So now when we look at these square roots, okay, we can see that the number under the radical is the same. But let's go ahead and finish up this last piece because there's also a perfect square that goes into 300. 100 is a perfect square, and 100 times 3 is 300. So now I give each their own radical symbol, and this becomes 6 times 10 times the square root of 3, or 60 square root of 3. And now we can see that all of these are the same radical. So now we can take 14 minus 15 gives us negative 1 square roots of 3, add 60, and that gives us a total of 59 square roots of 3. And so now that is our answer, and we can find that right here. All right, so that is some more simplifying, and that is the end of this video.